So today we're going to look at what's called the lone candidate test. It's not in your textbook, but it is something that you should understand. So the lone candidate test is used primarily when you have an open interval instead of a closed interval and you're trying to find an absolute maximum or an absolute minimum. That said, you can also use it on a closed interval. But here's what has to happen. If f is continuous on an interval from a to b, open or closed, and x equals c is the only critical point, so you only have one critical point, then f has an absolute maximum of f of c if f has a local maximum at x equals c. And f has an absolute minimum of f of c if f has a local minimum at x equals c. So what this allows you to do is transfer from a local argument to a global argument. But there can only be one candidate. Okay? In the interior of the interval, at least. Right? Normally you would test the endpoints and the other one, but let's take a look at how this works out. So for each function, find the maximum and minimum value, if they exist, on the domain given. Justify your answers. Okay. So for this one, we are going to be allowed to use a calculator for this because the numbers are just horrible. But we need to start by taking the derivative. So that'll be the denominator, 3x, times the derivative of the numerator. So that'll be cosine x minus the numerator times the derivative of the denominator, which is just 3, all over 3x quantity squared. Just to simplify matters, I'll note that I can factor a 3 out of all of that and cancel one of them on the denominator and cancel both these in the numerator. So that's going to be x times the cosine x minus the sine of x all over 3x squared. And I want to find where that's equal to 0. Turn all my stat plots that I'm using today off. So x cosine x. Be sure to close the parenthesis at the end of that. Minus sine of x over 3x squared. And we want this on the interval from 0 to 5. And we're only interested at where it changes sign. So I make the y window pretty tight. I usually do it from -1 to 1 so that I can see any zeros pretty easily. So my window, I'm going from 0 to 5 by 1s. And then from -1 to 1 by 1s. Okay. That's not what I expected at all. Did yours look like this? All right, I must have typed something wrong. X cosine x minus sine x Oh, I was playing with something the other day and changed it to 2 degrees to see what happened. I'm like, I'm like, this is totally unexpected. Come on, go up above. And even at that tight a window, it's difficult to see, but it did go above. So I'm going to tighten up the Y window even more to make it, just to make sure that what I thought I saw is what I actually saw. So negative 0.1 to 0.1 by 0.1. This should be a bit more dramatic. So it looks like that. Okay. So we know a couple of things. Since f prime went from negative to positive at whatever this x value is, we know we're going to have a local minimum on the graph of f. Yeah. So let's find that value. It's somewhere between 4 and 5. I guess 4.7. Oh, wow. Really badly off. 4.493. Since f prime changes from negative to positive at x is equal to 4.493, f has a local minimum at x equals 4.493. Of f of 4.493, which is equal to, let's see. Now, when you go back to your calculator, one of the nice things is if you quit out of this, if you just type x, it has that in its brain because that's the last x value that it calculated. So as long as you don't go back to the graph and move anything around, it's going to keep that value in its head. So I want it to tell me, well, what is the sine of x divided by 3x? If you do it with a slash, you got to put parentheses around the x because otherwise it does sine of x divided by 3 times x. This is part of the reason why I suggest a lot of times that you really ought to use the horizontal fraction. So this is negative 0.072. So we've established, first of all, that we have a local minimum. And then you have to go back and go, all right, because it's the only candidate, so since x equals 4.493 is the only critical point, of f on the open interval from 0 to 5, negative 0.072 is the absolute minimum of f on the open interval from 0 to 5. And we can also say at this point that because the end point of this interval, there's a hole in the graph there, basically, right? Because we don't include 0 and we don't include 5, and f has no absolute maximum. For this next one, we have an open interval of all x values, right, all real numbers. This one didn't say calculated. Let's try it without it and see what we can do. So I would rewrite this as y is equal to 20 times 1 plus x squared to the negative 1 and do the chain rule. You can do it with the quotient rule if you want. It ends up being about the same thing in terms of difficulty. So this would be negative 20 times 1 plus x squared to the negative 2 times 2x because of the chain rule. So that's negative 40x over 1 plus x squared quantity squared. And we'll set that equal to 0. The only place that's equal to 0 is that x is equal to 0. If we look at a number line analysis, if x is negative, my numerator is positive, my denominator is always positive. So here, f prime is positive, which means that f is increasing. If I substitute in a positive value, my numerator is now negative, my denominator is still positive, so f prime is negative here, which means that f is decreasing. So, since f prime of x changes from positive to negative at x is equal to 0, f has a local maximum at x is equal to 0 of f of 0. Oh, there was no f in this, was there? Now, if you do that on the AP exam, they tend to look the other way. They're like, oh, they just misspelled f is the joke. It's not a very good joke, but you really shouldn't suddenly change it. It should be of y of 0, which is equal to 20. Since the only critical point of y is at x equals 0, 20 is the absolute maximum of y, and y has no absolute minimum. Although it is bounded on the bottom, it turns out that as x gets bigger and bigger, my fraction gets closer and closer to 0. So again, having a boundary and having a minimum, not necessarily the same thing. Any questions about that? So tonight's assignment on global extremes, it's not all lone candidate tests. There are some of those mixed in with some of the other. Okay?